everyone. Today we're going to talk about weight of water, averages, and acceleration due to gravity. 1 liter of water weighs 1 kilogram, and this is a fact that will be useful in many questions. 1 milliliter equals 1 gram, 1 liter equals 1 kilogram. So there are 60 minutes in 1 hour and 60 seconds in 1 minute. So there are 3,600 seconds in 1 hour. 1 liter of water has the volume of 10 centimeters by 10 centimeters by 10 centimeters. So 1,000 liters of water have the volume of 1 meter by 1 meter by 1 meter, which is 1 cubic meter. And that is also used in many of the questions related to water. So this is a cubic meter, and it is equivalent to 1,000 liters. That's how much space 1,000 liters of water would take up. And 1 milliliter would take up 1 cubic centimeter, and 1 liter would take up 1,000 cubic centimeters. So let's get into some questions. What is the net weight of a 4,280 liter tank of water? Well, remember from up here, we said that 1 liter of water is 1 kilogram. So if each liter of water is 1 kilogram, then it'll be a number of kilograms equivalent to the number of liters. So it would be 4,280 kilograms. So that would be the answer. A water line has 900 meters of 15 centimeter diameter ductile iron pipe. At a pressure test of 1,000 kilopascals, 414 liters of water is added over a period of 4 hours. What is the leakage rate? So what we're going to do is we're going to figure out what the leakage rate is. And I'm going to use some of my tools here to write. So a water line has, sometimes problems have extraneous information, which means information that you don't really need to solve the problem. So all we need to do here is we need to figure out the leakage, which is equal to the volume in liters over time. So the volume is 414, and that's over 4 hours. So it's 414 liters over 4 hours. I'm going to just stop the full screen here so that I can grab my calculator. 414 divided by 4, we get 103.5. So that'd be 103.5 liters per hour. So that would be answer B here. Okay, so how long will it take to fill a ground storage tank that holds 240,000 liters using a pump with an output of 400 liters per minute? So if the storage tank uses 240,000 liters, well, holds 240,000 liters, and the pump has an output of 400 liters per minute, that means that it would be 60 times that per hour because there's 60 minutes in each hour. So 400 liters times 60 minutes per hour . So that gives us 24,000 liters. And then what we want is we want to have 240,000 liters. 240,000 liters divided by 24,000 liters. And we get 10. So it's going to be 10 hours. So it's 24,000 liters per hour. So it's 10 hours. So it'll be answer A. An average, which is also called a mean, is the total values of a set of numbers divided by the number of numbers. So the formula is average, which is their arithmetic mean, is equal to the sum of all of the terms divided by the number of terms. So let's do a question. So calculate the average wastewater flow over a 7-day period from the data collected below. So remember that the average is the sum of all the terms divided by the number of terms. So I would use a calculator and I would add all of these numbers together. I know it's for 1 week, so I know that the number I'm going to end up dividing by is 7. So 328 plus 430 plus 485 plus 357 plus 452 plus 389 plus 487 equals, and we divide that by 7, and we get 418.29 when rounded to the second decimal place. And that would be meters cubed per day because it's the average of the wastewater flow, which is in meters cubed per day. So that would give you answer B. Ratio problems are solved by cross multiplying. So that means multiplying the top of one of the fractions by the bottom of the other fraction, or the numerator by the denominator, and then the other numerator by the other denominator. So usually the reason we are using ratios to solve problems is that one of the 4 values is unknown. Once we cross multiply, we can easily solve for the unknown value. So let's do another question. If 3 kilograms of alum are required to treat 5,000 liters of water, how many kilograms are required to treat 40,000 liters of water? Well, how many times greater is 40,000 compared to 5,000? So what I would do is I would set it up as 3 kilograms is to 5,000 liters as how many kilograms, so that's our X, that's our unknown, that's what we want to find, is to 40,000 liters. So there's a couple ways actually that you could go about it. You could think, well, how many times does 5,000 go into 40,000? You could do division there, and so that your calculator would help you. So 40,000 divided by 5,000 would be 8. Then you'd multiply the 3 by 8 and you get 24. Or we can do cross multiplication like we talked about. So 5,000 times X gives us 5,000X. Excuse the writing with a mouse, please. Equals 40,000 times 3 is 120,000. So now we divide both sides by 5,000. So we're running out of space here. Let me just make some more space. So 5,000 X divided by 5,000. So the 5,000s will cancel each other out and you'll be left with X. And 120,000 divided by 5,000. So I know that these zeros will cancel out with these zeros. And now it's a matter of 120 divided by 5. I could use a calculator if I needed to or wanted to, but I know that 5 goes into 24 times and that there are 6 groups of 20 and 120. So 6 times 4 is 24. So X is 24. So we would need 24 kilograms. So our answer would be B. So now here, another piece of information that is also important to know is that any object's motion that is under the influence of the Earth's gravity is subject to acceleration due to gravity, which is 9.8 meters per second, which is also written as 9.8 meters per second squared, or as 9.8 meters, and then the seconds to the -2, because when you have a positive exponent on something in the denominator, you can write it in the numerator, or just like on top like this, with a negative exponent instead. So acceleration due to gravity, so gravity is 9.8 meters second to the -2, and absolutely any, so this obviously includes water, object's motion that is under the influence of the Earth's gravity is subject to the acceleration due to gravity, which is 9.8 meters times second to the -2 downwards. So we use the formula power kPa equals head in meters times 9.8, where kPa is the pressure in kilopascals and head in meters is the height of the head of water in meters. This equation can be rearranged in order to solve for head meters by dividing both sides of the equation by 9.8. This then becomes the kilopascals of pressure divided by 9.8 equals the head in meters. So now that we know this, let's do some more questions. So if a fire hydrant requires a nozzle pressure of 350 kilopascals, which is 50.8 pressure per square inch, the head of water used to supply this formula is kilopascals of pressure divided by 9.8 equals the head in meters. So what we do is we plug in what we know. So the kilopascals would be 350. And then we're going to divide that by 9.8. And that gives us the head in meters. The head in meters. Okay, so we're going to use our calculator. And we're going to do 350 divided by 9.8. And we get 35.71, so 35.7, so it would be answer C. So next, if the water level in an elevated tank is 41.3 meters, which is otherwise known as 135.5 feet, above the ground surface, the pressure at a tap on a line on the ground below the tank will be about. So what will the pressure be about? Well, we use the formula kilopascals equals head in meters times 9.8. So we're going to use the text, and so just here, I'm going to enter in what I know. So the kilopascals is what we're trying to find. So we will not know that, but we know that the head in meters is 41.3. And that's being multiplied by 9.8. So now I use my calculator to calculate that. Oh, my calculator does not want to cooperate. Just a second. Okay, so I got my calculator up here, and that seems to have vanished, unfortunately. But we know that we were multiplying the head in meters by 9.8, so that would be 41.3 times 9.8, which gives us 404.74. So if we round it to the nearest kilopascal, we get 405 kilopascals, so that's answer C. Now here are some words of general advice. So you will need to complete a quiz and submit your answers in order to earn the CEUs. And remember that whenever you're writing a multiple choice test, you should eliminate wrong answers to make answering the questions easier. Do not spend too much time on any one question. If after you eliminate wrong answers, you still cannot hazard a guess, leave the question and come back to it later. That's more so for time tests. You will not be timed on your quiz, but in case you're doing any tests for further levels of certification. While we do not use the units while doing the calculations in math, it is still very important. So we did use some units there. That was some fairly basic math, but when you get into more complicated math, you don't usually want to use the units because it makes it too complicated, and then you also might think that some of the letters for the units are variables. So it is still very important to make sure that your result is in the same unit as that of the answer. Also, it is often easier to convert the units at the beginning of the question. Remember to use the formula sheet that you are given when you do your levels of certification tests, and to use your calculator. Now for the quiz, you will be given the formulas like this that correspond to the questions, and of course you can use your calculator. So best of luck with your quiz. I look forward to seeing your answers, and have a great day.